Hello, today we are going to start Unit 7, which is the unit on factoring. And we are going to start off with learning how to find GCFs. This is something that we have learned previously before algebra, and we are going to relearn this skill now. So first we just want to think of what are the numbers that multiply to 36, positive 36. So for 36, we could have numbers like, we could have 1 and 36, 2 and 18, 3 and 12. We could have 4 and 9, 6 and 6. And just in case you weren't sure, you do 36 divided by 1. That means what you divided by, and the answer is what can multiply to 36. Then 36 divided by 2. If I do 36 divided by 5, that one gives me a decimal, so I wouldn't write that down. Let's see, 36 divided by 7, no good. 36 divided by 8, 9, I already got. Once you see a number you already got, we're done with our list. All right, so let's also think about, is there any negative numbers that can multiply to 36? Well, if I do negative 1 times 36, that's negative. If I do 1 times negative 36, that's negative. But what about negative 1 times negative 36? Oh, so I could either have both of them being to get a positive. I could either do a negative times a negative or a positive times a positive. But to get a negative, I do a negative times a positive or a positive times a negative. So to get positives, they have to be the same sign. To get negative, one has to be negative, one has to be positive. All right. So today we are going to learn how to find these greatest common factors. What is a greatest common factor? This is the largest number, and we will also learn how to do this with variables today, that can be factored out of any two or more terms in a polynomial expression. So, for example, if we wanted to find the factors of 12 and 16, I would write down all the numbers that can multiply to 12, all the numbers that can multiply to 16. And I circled the common factors, but I'm worried about the greatest common factor. The greatest common factor of them is 4. That's because 12 divides by 4 evenly, and 16 divides by 4 evenly. And we're left with a remainder of 3 and 4. We're left with the other factor of 3 and 4, and there's nothing we can take out of those. Then also, if we're trying to find the GCF of a variable, if we have 2 x's, and we have 2 y's in our first term, and then our second term we have 1 x and 4 y's, our GCF is how many x's they both have. They both have 1 x. I can't say they both have 2 x's because they only both have 1 x, and they both have 2 y's, making our GCF the 1 x and the 2 y's. So let's chart this. Find the GCF of 32 and 48. I'm going to start by thinking, what are the numbers that can multiply to 32? 1 and 32. 2 and 18. Right now we're only going to worry about the positives. 3. Does 3 work? 32 divided by 3? Nah. 32 divided by 4? That works. 4 and 8. 32 divided by 6? Nope. So I think that's it. Alright, let's try 48 now. 1 and 48. 2 and 24. Does 3 work? 48 divided by 3? 3 and 16. 48 divided by 4. 5's not going to work, I know, because 5 only works if the number ends in a 5 or a 0. 48 divided by 6. 6 and 8. Alright, so this means that our GCF is, I'm just going to double check, could it be 18? No, it couldn't. So our GCF is 8. Alright, now I'm going to show you another way, the way that I like better. I look at the biggest number. The biggest number here is 60. So I take 60 and I start writing down all the factors of 60. 1 and 60, 2 and 30, 3 and 20, 4 and... I had stuff in my calculator. 4 and 15, 60 divided by 5, 5 and 12. 6 and 10. 7's not going to work. Does 8 work? 8 doesn't work. 9, no. Okay. Now, My smallest number here I have is 24. So I need to look at all the factors under 24. The ones that are over can't be a possibility because your GCF can never be bigger than a number. So let's start with 20. I'm going to try to divide both of these by 20. If they don't both work evenly, then it's not our factor. Nope, not going to be 20. All right, now let's try 15. 24 divided by 15. Nope, doesn't work. All right, we're just going to continue going down the line. Let's see 12. 24 divided by 12. So far that could work, and 48 divided by 12. That works too, so our GCF is 12. Nice, nice, good job. All right, now I want you guys to practice. You can use either method you want. I like that second method better, but you can use either one that you like. All right, I'm going to take the bigger number. The bigger number is 80. I'm going to find all the factors of 80. 1 and 80, 2 and 40, 80 divided by 3, no good. 80 divided by 4, yep, 4 and 20, 80 divided by 5, 5 and 16, 80 divided by 6, 80 divided by 8, 8 and 10, 9 is not going to work. All right, that's it. Now let's look at all the numbers under 12. So it could be this, 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 and this. All right, I know 12 does not divide by 10, 12 does not divide by 8, but it does divide, oh, it doesn't divide by 5. It does divide by 4. So our GCF would be 4, because 12 divided by 4 equals 3, and 80 divided by 4 equals 20, and there's no number that I could take out of 3 and 20, so that is my GCF. All right, over here, let's look at the biggest number. The biggest number is 44. Let's write down all the factors of 44. 1 and 44, 2 and 22, 4 and 11, 44 divided by 6, no good. 8, no good. All right, that's it. So now my smallest number here is 18. I need to choose all the numbers 18 under 18, which are these numbers. And let's try to divide. 18 divided by 11, no good. 18 divided by 4, no good. 18 divided by 2, that works. And 20 divided by 2, that works. So our GCF is 2. And to check if you're right, you take each number and divide it by the GCF. So 18 divided by 2 is 9. 20 divided by 2 is 10. And 44 divided by 2 is 21. 22, I meant. And there is no number that I could take out of 9, 10, and 22, so my GCF is just 2. All right, now let's try finding the GCF of variables. So let me show you how we figure this out. The first one is a to the fourth, which means we have 3 a's, and b to the third, which means we have 3 b's. Then the next one is a to the second, which is 2 a's, and b to the fifth, which is 5 b's. Our GCF is just how many of the same of the letters you have. Both of them have 1 and 2 a's, and both of them have 3 b's. So our GCF would be a to the second, b to the third. To find the GCF, you look at each letter. So first we have a to the fourth and a to the second. Because 2 is smaller, that means our GCF would be a to the second. And then we have b to the third and b to the fifth. You want the smaller one. I know it's weird because you're looking for the greatest common factor, but you need the smallest amount because that would mean that both of them have that many of that variable in the term. So the next one, I have r to the third and r squared, which would make my GCF the smaller one, r squared. And then I have t to the first and t to the fourth, which means my GCF would be t. Both of them don't have a q, so this is just my GCF. All right, let's look at the next one. They both have m squared, which means my GCF would be m squared. One has an n to the first, one has an n to the third, which would just make my GCF n. This one, I have x squared and x to the third, making my GCF x squared. Then I have y to the first and y to the second, making my GCF just y. And they both don't have a z. All right. Now we need to try to put together everything we learned. How do we find a GCF of a number and a variable? So start with our bigger number, which is 36. Let's find our factors of 36. 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Look for all those ones under 24, so it could be any of these. And let's try to do it. 24 divided by 18, not going to work. 24 divided by 12, that works. So our GCF is 12. And then we have an x in one, but we don't have an x in the other, so we can't say x. And then they have a y to the third and a y squared. So they both have at least two y's, making our GCF y squared. Now we need to find the GCF of 105, 30, and 75. Let's actually start by finding the GCF of the smaller number, which is 30. So we would have 1 and 30, 2 and 15, 3 and 10, 30 divided by 4, I don't think that works, 30 divided by 5, that works, 5 and 6, okay. So, let's see, does 30 go into both of them? No, it's not going to work. Does 15 go into both of them? Oh, 15 goes into 105, 15 goes into 30. Does 15 go into 75? It does. So our GCF would be 15. They all have an x, but they don't all have a y, so our GCF is just 15x. 105 divided by 15, it gives us 7. 30 divided by 5 gives us 6. And 75 divided by 5 gives us 15. There's no number that we could take out of 7, 6, and 15. So yeah, actually you only need to find the factors of the smallest number. That's even easier. So now try this. Alright, let's start by finding our factors of 30. 1 and 30, 2 and 15, 3 and 10, 30 divided by 4, 30 divided by 5, 5 and 6, alright. Let's see which one goes into 66. 66 divided by 30, no good. 66 divided by 15, nope. 66 divided by 10, nope. 66 divided by 6, that works. So our GCF would be 6. This one has an x to the first and an x squared, so choose a smaller exponent, so just x to the first. This one has a y squared and a y to the first, so just y. So our GCF is 6xy. Now we have 140, 140, and 80. Let's find the factors of 80. 1 and 80, 2 and 40, 80 divided by 3, no, 80 divided by 4, 4 and 20, 80 divided by 5, 80 divided by 6, 80 divided by 8. Alright, let's see, 140. Does 140 divided by 80? Nope. 140 divided by 40? Nope. 140 divided by 20? That works. So GCF is 20. They all don't have an M, and they all don't have an N, so our GCF is just 20. And now, sometimes you might not be given the GCF separated, the term separated. You might just be given to it where it looks like a polynomial. But we're just finding what is the GCF of 10 and 25. Smaller number is 10, so let's write down the factors of 10. 1 and 10, 2 and 5. 10 can't go into both of them, but 5 can. So our GCF would be 5. Then we have x to the fourth and x squared, so it would just be x squared because you choose a smaller exponent. This one, we have a 20, 12, and 28. 12 is smaller, so I'm going to write down my factors of 12. And now let's see. Does 20 divide by 12? Nope. Does 20 divide by 6? Nope. 20 divided by 4? Yes. Does 28 also divide by 4? Yes. So our GCF would be 4. And the smallest exponent is x to the first. Alright, let's try this one. 12 and 18. So write down 12, 1 and 12, 2 and 6, 3 and 4. 18 does not divide by 12. 18 divided by 6 works. So we'd have 6. And they both have the x to the first. Because that's a smaller exponent. Then 24, 16, and 8. 8 is my smaller one. So 1 and 8, 2 and 4. 24 divides by 8. Yes. 16 divides by 8. Yes. So our GCF would be 8, x to the third, x squared, x to the first, so just x. And this is a rapid regions review. When written in standard form, remember standard form means highest exponent first to lowest. So let's make sure they all have that. I would have to get rid of choice 4 because this has the highest exponents in the middle. Everything else looks good. All right. Product means we multiply, so let's get down to doing that. We're first going to multiply this 3 by both terms. 3 times 2x is 6x. 3 times -5 is -15. So I think I'm going to have this -15 in it. X times 2x is 2x squared. So I think I'm going to have these 2x squareds. And x times -5 is -5x. And now let's write these in order. 2x squared. Then 6x minus 5x is -1x. No, positive 1x, and then -15. Which is answer choice 2. Nice job. And that sums up our lesson on finding the GCF of polynomials, the terms, and such.